Hi, in the last session, we talked about the supervised machine learning and talked about the classification and regression tasks. Now, in this session, we will be talking about unsupervised machine learning and reinforcement learning. So, what is unsupervised machine learning and why we needed it? As we mentioned that the labeled data is the most important ingredient in the supervised machine learning, which is actually not an easy task to have. Sometimes it is very expensive or time-taking to collect the good training dataset and required lot of steps from cleaning of data to finalizing the training dataset. So here is the concept of unsupervised machine learning comes. In unsupervised machine learning, we do not need the labeled dataset. So the question is that how unsupervised machine learning works with the unlabeled data. So here is the concept of clustering comes when you provide lot of sample data to the machine learning model for which the output is not known. The machine learning model identifies the common factors in the input data. However, the output is unknown, but the machine learning model will know that something in the data is common, and based on that common factor, machine learning model will segregate the input data in some groups. These groups are normally called clusters, and the machine learning model will give some ID to the specific cluster. Means at the output of unsupervised machine learning model, you will have the output where the each input data point are grouped with the other data points based on some common factors within those points. You can understand it with a simple example in the screen. Another important type of machine learning is reinforcement machine learning. This is the completely different approach from what we have learned because this machine learning model do not use any type of labeled or unlabeled data for the training of models, but instead this machine learning model learns from the actions. This is the concept where machine learns from the trial and error method, same like we humans learns. Like we take some decisions for the current situation, then we analyze our action. If that action improves the condition or worsens the condition, and based on that feedback, we learn if that action was good or bad for that specific situation. Like how the human learns that how to ride a bicycle. We starts riding, then falls down and learns something, then we try, then falls, now learns more. So with every fall, we learn something new, and by the multiple attempts of bad feedbacks and learnings from them, we learn that how to ride a bicycle. Same way, how we learn to improve our gameplay for any game, we learn from the actions and the feedback. Reinforcement learning works on the same principle. Machine learning model can take any action from the possible actions in the current environment. Then after action, model will analyze the environment again. If that new environment is one step closer to the given specific task, it will be rewarded as a positive feedback. But if the environment goes worse, it will be considered as a bad decision and a negative feedback will be recorded. And by the multiple attempts of actions and feedback, finally a machine learning model will develop. The goal of developing this type of machine learning is to achieve maximum possible rewards so that model can be able to take the decisions in the dynamic environment. Isn't interesting? For me, it's super exciting. Maybe you can relate some of the use cases of reinforcement learnings from the network perspective. If you can think of any new function which you can develop using the reinforcement learning or unsupervised machine learning, let us know from the comment section. In the next session, we will know machine learning models in little deeper. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.